Today, we will take you on a journey, a fascinating journey. It's a journey of rebuilding, renewal and revival of a diesel-electric locomotive after 18 years of its commissioning, when it completes off half of its coda life. The journey takes place at Dmw Patiala, the only unit of its kind in the country that is engaged in the rehabilitation and remanufacturing of Alco diesel electric locomotives. Apart from the locomotive, the participants in this journey are the technical staff of DMW, and as we take you through the various stages of this journey, you will get to know how skilled and well-equipped they are to discharge their roles with full dedication and commitment. This skill enhancement and sharpening happens at the Technical Training Center, that is TTC, that was set up in 1988 and is equipped with state-of-the-art facilities to meet the most comprehensive training needs. To equip the manpower with necessary skills, TTC conducts various courses like Induction Course, Refresher Course, Supervisors Development Program, Promotional and Pre-Promotional Training. TTC organizes special courses which include CNC machine programming, CNC machine maintenance, first aid, industrial safety and firefighting. The center also provides training to ACT apprentices of 6 different trades. Our first stop is the center's library that contains more than 1200 technical and other books which serve as an invaluable knowledge bank for ACT apprentices, trainees and TTC staff. The center also has an air-conditioned seminar hall equipped with LCD projector, electronic copy board and a seating capacity of around 110 that is ideal for holding seminars and meetings. Then there is the electrical lab equipped to provide training in the electrical aspects. There is also a model room equipped with 62 models of mechanical and electrical trades. One working cut model of loco power pack is provided to illustrate the functions of different components. Safety items are also displayed here. The training center has one air-conditioned mechatronics lab having sitting capacity of 25 trainees and is provided with pneumatic and hydraulic trainers, virtual welder and diesel simulators. Training is provided to the machine maintenance staff of DMW and zonal railways on the hydraulic and pneumatic trainer to familiarize them with the different types of valves, their functions, and to practice the circuits on the workstations. Training is imparted to welders using the virtual welding kiosk, which saves material, electricity and other welding consumables like electrodes and flex, besides ensuring that there is no pollution through emission of smoke. Training is given to DMW staff and ACT apprentices on virtual reality-based stereoscopic 3D maintenance training kiosk to help them learn different types of modules on tappet phasing, water pump assembly, crankshaft preparation, fitment of crankshaft, split gear, camshaft and cam gear fitment. Apart from all this, training center is equipped with 12 conventional and 2 CNC machines for training zonal railways and DMW staff. Let's now embark upon the journey of the core activities of DMW. DMW is engaged in 2 major activities, viz. Rebuilding and manufacturing of new Alco locomotives being carried out by Loco Rebuilding, that is LR Group of Shops. Manufacturing of components and rehabilitation of sub-assemblies of Alco locomotive for LR shop and zonal railways are carried out by supporting shops, about which we will get to know shortly. Now we will start our journey from Loco Rebuilding Shop, where old locomotives are received and dismantled for repairs. First of all, old Dmw locos are received in loco stripping section, where all loco items like power pack, bogies, electrical components, air brake components, hood etc. are stripped out and sent to their respective shops for repairs and rehabilitation. After stripping of bogies from locomotive in LRS, these are sent to bogie shop for rehabilitation. Now let's have a look at the activities of bogie shop. Old bogies from loco rebuilding shop are received in bogie shop for major rehabilitation. It has following main sections: stripping, frame furnishing, press, bearing and machining, final assembly and bogie testing. Old bogies received from LRS are stripped out in stripping section. Traction motors are removed and sent to TMS for further rehabilitation. All other components are also stripped and are used if found in usable condition. Cleaned bogie frames undergo complete testing, including trammeling, crack detection etc. as per RDSO norms. If found within the service limits, then welding of cracks is done. Conventional bogies are converted to high-speed bogies with suitable modifications. Bogie frame is then stress relieved in heavy machine shop. The other old serviceable components, for example, springs, levers etc. are also cleaned properly before reuse. Serviceable springs and new springs are tested on CNC spring staging machine. All its important parameters are electronically recorded. New or old springs are paired according to their observed working heights. Old serviceable or new unfurnished bogie frames are furnished in the frame furnishing section. All the brake rigging components and liners are assembled and welded here. Suspension tube and high-speed taper roller bearings are fitted on the axle, and then wheel discs are pressed at both ends on CNC wheel press machine at a pressure ranging from 95 tons to 132 tons. The data is recorded electronically for each axle. After wheel pressing, wheel disc profiling and line gauge, that is, distance between two wheel discs are maintained on CNC wheel profile machine. Tread diameter between 1092 to 1097 mm and line gauge 1599 plus minus 0.5 mm are maintained. High-speed axle boxes with roller bearings are mounted on both ends of the axle journal, and 1.5 kg grease is filled in each axle box. Traction motor is then mounted on the axle's suspension tube after ensuring the proper backlash between bull gear of axle and pinion of the traction motor. Gear case is fitted and 9 kg cardium compound is filled in each gear case. Traction motors and gear case mounting bolts are properly tightened to the prescribed torque value of 145 kg-M with the help of electronically operated digital torque wrench. Motorized axle wheel set assemblies are properly spaced and furnished bogie frame is pre-lowered on these with the help of EOT cranes. Proper lateral and longitudinal clearances are maintained before final lowering. Complete bogie is then tested at a maximum speed of 500 rpm, which corresponds to approximately 100 km per hour speed in the CNC bogie testing rectifier. All important parameters and temperatures are recorded electronically in the computer. Complete bogie is painted before dispatch to LRS. After stripping of power pack from locomotive in LRS, it is sent to power pack shop for rehabilitation. Now we will proceed to power pack shop. Power Pack Shop is primarily engaged in assembly of power packs for rebuilt and new locomotives, as well as supply to zonal railways to meet their requirements of unit exchange. It has following main sections: stripping, block assembly, main assembly, power assembly, sub-assembly, reconditioning, and testing of power packs at test bed. Old power pack received from LRS is stripped out in the stripping section, and the stripped traction alternator or generator is sent to TMS, while the engine block is sent to HMS for further rehabilitation. Here, other components, for example crankshaft, cylinder head, etc., are stripped from power pack. Some components are used after cleaning and inspection if found in usable condition. Engine base in serviceable condition is cleaned and used in power packs assembly. The old serviceable components like cylinder head, steel cap piston, cam gear, oil seal, oil catcher, etc. are reconditioned, inspected and sent to zonal railways to meet their requirements. Block is mounted on manipulator after deburring. Thereafter, cam bush, liner sleeves, cylinder liners, crankshaft and power assembly are fitted, maintaining specified parameters. Then, block is shifted to main assembly section, where it is placed on engine base. The balance assembly is carried out after TDC transfer to main engine base. Cylinder head exhaust manifold, traction alternator, turbo support, turbo supercharger, FIP support, fuel injection pump, cam gear, etc. are fitted with specified clearances and backlashes. In power assembly section, piston pin after hydraulic testing at 10 kg per square centimeter and con rod assembly with small end bush are assembled with proper interference. In this section, cylinder heads are also assembled while maintaining blow-by not less than 45 seconds. In sub-assembly section, lube oil pump, water pump, fuel injection pump, support assembly, overspeed trip assembly, control shaft and valve levers are assembled. After assembly of power pack, the performance of power pack is checked in power pack testing section at test bed. To check the performance, fuel oil, lube oil, water and electrical connections are made at test bed and the engine is run as per instruction manual. During testing, all important parameters, for example, compression and firing pressure, fuel pressure, lube oil pressure, booster air pressure, vibration, sump vacuum and various temperatures are observed and maintained. The power pack is now ready for use. After stripping of engine block from power pack in power pack shop, it is sent to heavy machine shop for rehabilitation. Now, we will proceed to heavy machine shop. Heavy machine shop manufactures and rehabilitates all types of Alco engine blocks. Traction motor housings of Dmw and Alco locos are also rehabilitated. The shop has sophisticated NC, CNC and state-of-the-art machines which include CNC robotic welding system, numerous MIG welding sets and EOT cranes. HMS is divided into various sections like welding section, machining section, fitting section and inspection. Eco-friendly electrically operated washing plant is used for washing of engine blocks. Engine block is held in a fixture which rotates at the speed of 2 rpm. Its washing cycle time is 1 hour. Orion compound mixed with water is heated at a temperature of 70 to 80 degrees centigrade. Old engine blocks and various types of magnet frames are MIG welded manually to repair worn-out portions. Robotic welding system is used for the welding of engine blocks. This is a floor-mounted robot having 6 rotational axes with payload of minimum 15 kilograms. The robot axis is controlled by independent AC digital servo motor and drive with 0.1 mm repeatability. The robotic welding system has the advantages of reduction in manpower, improvement of cycle time and increased rate of production, consistency in welding and setting flexibility in welding parameters. The filler material being used in the system is copper-coated welding wire. Argon and carbon dioxide mixture is used as shielding gas. The stress-relieving furnace is used to relieve internal stresses of magnet frames and engine blocks which develop during welding. It also increases machinability of components. The components are heated at the rate of 70 to 80 degrees centigrade per hour up to 650 degrees centigrade and held at that temperature for soaking period of 4 hours. After that, cooling starts at the rate of 70 to 80 degrees centigrade per hour with door closed till temperature reduces to 200 degrees centigrade. Thereafter, the door is opened and components are allowed to cool in air for machining. This is a state-of-the-art 5-axis traveling column type CNC horizontal boring and milling machine having 8-micron accuracy. It is used for machining of engine blocks. The operations like boring of crank and cam bores, top deck and middle deck bores, facing and serration cutting and all type of drilling and taping operation of engine block are carried out on this machine. Automatic tool changer supports up to 48 types of tools which work as per the CNC program. The various taped holes of Alco engine blocks get damaged in due course of time during the running of locomotive. During the process of remanufacturing of engine blocks in HMS, these fixing holes of Alco engine blocks are enlarged, followed by plug fitment and welding for re-drilling and retaping of the holes on radial drilling machine. WMW made CNC horizontal boring and milling machine is used for the machining of various types of magnet frames of Alco locos and Dmw. Its positioning accuracy is 0.020 mm and its rotary table can be indexed in 360 degrees. The machine is having the spindle RPM range of 5 to 3000. After stripping of traction motor and alternator from power pack and bogie, these are sent to traction machine shop for rehabilitation. Now we will have a round of traction machine shop. Traction machine shop is engaged in manufacturing of new Alco and HHP traction motors and alternators. It also repairs and rehabilitates old AC and DC traction machines for BG and MG Dmw as well as Alco and HHP locos. A typical DC traction motor undergoes many activities during its rehabilitation, which will now be explained. For old motor, it starts with visual inspection and dismantling of traction motor and frame. This is followed by disassembly, cleaning and drying of motor components in automatic washing and vacuum drying plant. Magnet frames are sent to trade or heavy machine shop for rehabilitation. Thereafter, the main field and interpole coils rehabilitated by DMW are fitted. New coils are also fitted as required. Armature repairs involves replacement of shaft if required, core loss test, cleaning, repair or replacement of commutator, rewinding of armature and stage testing, vacuum pressure impregnation, rotational curing, commutator machining and mica undercutting, total indicator runout, ovality check, dynamic balancing, anti-tracking paint application, and finally electrical tests. Bearings and its components are fitted on armature shaft. Manufactured or rehabilitated traction machines, for example, stator and rotor, are assembled in assembly section. Different parameters are checked before testing on test bed. Manufactured and rehabilitated traction motors and traction alternators are tested on test beds. Now let us see the coil making and insulation procedure of power coils. For this, conductor is cut into fixed length, then a volute is made and coil forming is done. After that, ends are flattened, followed by annealing and insulation. Then, varnishing, baking and molding is done. Finally, electrical tests are carried out to ensure quality. Now let us go through the working of Carbon Brush Shop, which manufactures different types of carbon brushes used in the traction motors and auxiliary machines of diesel-electric locomotive. DMW is the only production unit in Indian Railways that manufactures a diverse range of carbon brushes which are supplied all over India to different zonal railways for use in various types of locomotives. The primary function of a carbon brush is to deliver or collect current from a rotating part of an electric machine. Raw material used in CBS are E88/ELCA and EG14D/ACPL. The first step in the process is slitting, and it is done according to the size of carbon brush. After slitting, the length, breadth and height are grinded on the line grinding machine, and these are known as T, A and R dimensions. During the sliding of carbon brush in the pockets, some dust is formed and goes into these grooves to avoid sticking of carbon brush in the pockets. This is followed by the stamping process and marking of condemning line on each and every brush, which indicates the condemning limit of each category of carbon brush. Next, angular drilling and scraping of the holes is done on the special purpose drilling machines. As a result of the angular drilling and due to the cosine component, the pull-out strength is considerably increased. Dovetail drilling and slotting is carried out to fit the rubber top on the carbon brush. Pigtail, which is also called shunt wire, is then rammed into the already drilled and scraped holes. After this, operation pull-out testing of pigtails is done to check the pull-out strength. Next, lacquering is done and the pieces are kept in the oven to maintain the desired properties. This is followed by joining all the pigtails together by crimping, sleeving and punching the terminals. Tinning is done for better conductivity and to avoid the opening of pig during working. Lastly, final inspection of carbon brushes is done after completion of the entire process. Millivolt drop testing is done at test rig to complete the process of carbon brush manufacturing. Now, we will go through the main activities of light machine shop. In light machine shop, more than 200 components are manufactured, including various types of gears which are used in diesel-electric locomotive. Machines for cutting precise gears are generally CNC type and are often housed in temperature-controlled rooms to avoid dimensional deformation. The important components being manufactured are bull gears, camshaft gear, crankshaft gear, all types of pinions, all types of camshafts and stiffer camshafts, connecting rod assembly and armature shafts. CNC DMG turn mill center was procured from Germany and is used to manufacture camshaft, stiffer camshaft, armature shaft, extension shaft and GM camshaft. This German machine is used for the processes like drilling, countering, taping, reaming and chamfering for various components. This HMC, again from Germany, is used to manufacture FP support, armature shafts, extension shaft, lifter PR, con rod and cap and bearing spacers. Now let us see the process of gear manufacturing. First of all, gear bore grinding is done to make it fit for loading the gear on gear hobbing machine. All motions on gear grinding machine are rotary by revolving both the job and grinding wheel simultaneously. Then, gear hobbing is done. It is a machining process in which gear teeth are progressively generated by a series of cuts with a helical cutting tool called hob. All motions in hobbing are rotary. The hob and gear blank rotate continuously as in two gears meshing until all teeth are cut. After gear hobbing, gear grinding is done on gear grinding machine to get the required finish. Grinding involves the removal of unwanted material through an abrasion process. A rough surface is rubbed against a workpiece at such high speeds that it literally scraps unwanted material away from the job. Grinding is typically the last step in the gear creation process. After the gear grinding process, the gears are tested on the gear testing machine. On meeting all the parameters as per the check sheet, the gears are dispatched to user shops. Manual testing of gears with sophisticated instruments is also done. Now we will visit heat treatment shop where the various components manufactured in light machine shop and tool room are heat treated to maintain the desired properties. Heat treatment is the process of heating and cooling of the material to achieve the desired properties or to alter the physical and mechanical properties. Heat treatment processes carried out in heat treatment shop of Dmw are stress relieving, hardening, tempering, case hardening and case carburizing, induction hardening. Stress relieving is carried out on metal products in order to minimize residual stresses produced due to machining, cold working, shearing, cutting and welding in the structure, thereby reducing the risk of dimensional changes during further manufacturing. The component is heated in the furnace to a temperature below the critical range and held at temperature for a period of time and cooled slowly. Metal hardening is a heat treatment process in which steel is heated from 30 degrees Celsius to 50 degrees Celsius above the upper critical temperature. It is used to impart specific mechanical properties to a component in order to render it fit for use, keeping it at an appropriate temperature and then quenching it rapidly in water or oil. Tempering is carried out by preheating previously quenched, hardened or normalized steel to a temperature below the critical range, holding and then cooling to obtain the desired mechanical properties. Tempering is used to reduce the brittleness of quenched steel. The hardness and strength obtained depend upon the temperature at which tempering is carried out. Induction hardening is a form of heat treatment in which a metal part is heated by induction heating placed in an induction coil through which a high-frequency alternating current is passed and then quenched by sprays through numerous holes. The frequency of alternating current used depends on the object size, material type, and the penetration depth required. Case hardening is the process of hardening the surface of a metal object while allowing the metal deeper underneath to remain soft, thus forming a thin layer of harder metal called the case at the surface. The thickness of the hardened layer depends on the various process parameters. Let's now go to electronics lab, which repairs different types of printed circuit boards and conducts testing of other sophisticated electronic devices. Modern CNC machines utilize very sophisticated and advanced electronic systems. For in-house repairing and testing of the PCBs at component level, an electronic lab was set up with the various diagnostic equipments. 4 important equipments will now be explained. Automatic test equipment is used to test the mounted digital and analog devices through clipping, simulating, and comparing the output results. Impedance analyzer is used for testing the passive components like inductors, resistors, and capacitors. It measures value and quality factor at their operating frequency and band. Storage type curve tracer is used for testing of active components like diodes, transistors, SCRs. It draws voltage current characteristics of the components under test. Digital IC tester is used to test freshly procured ICs to ensure its suitability before fitment. Now we will come back to LR Group of Shops for compilation of all the assemblies and sub-assemblies for rebuilding or manufacturing of locomotive. LR Group of Shops comprise following shops: Loco Rebuilding Shop or LRS, Loco Stripping Shop or LSS, Transmission Shop or TRS, Air Brake Shop or ABS, Loco Test Shop or LTS, Loco Paint Shop or LPS. LRS is the Loco Main Assembly Shop. Here, old locos are stripped. Components and sub-assemblies received from the other shops and sister shops of LR Group are fitted and assembled to make the loco ready. Average life of Dmw DC Alco locos is approximately 36 years. After completing 18 years of service, these locos require rebuilding, also called rehabilitation, to utilize the full life of locos. During rebuilding, WD-M2 locos are upgraded and modified into WD-M3A 3100 or 3300 HP AC/DC locos with modern features. Main modifications that are carried out are microprocessor-based control system with REM lot, roof-mounted DBR with self-load feature, auxiliary power unit, IRA B1 brake system, crew-friendly cab, high-speed fabricated equalizer-less bogie, and AC/DC traction alternator with top-mounted rectifier. Now we will explain in detail the activities done in LR Group of Shops. After stripping out all components, underframe is submerged into the dip tank having caustic solution for cleaning. Then it is washed with pressurized water. After cleaning, it is sent to loco underframe section by EOT crane, where it is placed on trestless for repairing, welding and testing of fuel tank. Then underframe is placed on the manipulator for repairs of load pad, central pivot and cracks on the frame. After that, it is pushed forward for assembly work. The activities performed in assembly are laying out of car body, grid battery and control cables, preparation, testing and mounting of all electrical components and their connections. These components are microprocessor-based control system, BKT reverser, stick-type master controller, fuel pump motor, electromagnetic and electro-pneumatic contactors, relays, auxiliary power unit, cables and bus bar. Fitment of air brake panel, MR reservoir tank, air dryer, all air brake piping and connection, control desk, air brake valve and gauge testing. In assembly 2 stage, the activities performed are lowering of bogies received from bogie shop, lowering of power pack received from PPS, mounting of power rectifier, compressor lowering, alignment of power pack, compressor, horizontal shaft and ECC, fitment of radiator fan, fitment of all fuel oil and lube oil pipes, fitting of radiators and finally lowering of hood over engine. After completing these activities, loco is sent for pre-cranking test. Before cranking, all specified parameters are checked like fuel oil pressure, IR value of control and power circuits, water level in expansion tank, battery voltage as well as sequence check of all electrics, microprocessor-based control system and ground operation. After verifying the parameters in pre-cranking stage, the loco is cranked. During cranking, all specified parameters are verified like fuel oil and lube oil pressure, battery charging, no load voltage, engine RPM, etc. If any repairs are noticed, these are attended to. After successful cranking, various functions are checked like loco brake application, direction rotation of all traction motors, dynamic braking operation and working of safety items. Repairs, if needed, are carried out and then loco is sent to load test shop. In loco test shop, water load box testing is done to check and verify whether the engine gives designed output and whether all systems are functioning properly. During load box test, output of traction alternator is disconnected from traction motors and connected to water load box. Following main parameters are checked during load testing on all notches: fuel oil pressure, lube oil pressure, booster air pressure, engine RPM, brake horsepower, voltage and current, engine temperature, overspeed trip assembly, radiator fan RPM, LCR position and fuel rack position. After completing load box, all defects or repairs which are noticed during load box are attended. After repairing defects, loco is sent for road trial to check the performance in running condition. After road trial, all defects or repairs which are noticed during road trial are attended by concerned shops and sections. All specified parameters and safety items are rechecked. For example, self-load test, working of auto flasher system, VCD operations, air braking testing, etc. Then, loco is sent to paint shop for final painting. After painting, furnishing of loco is completed. For example, driver cabin, seat, covers, sun visors, etc. are fitted in LRS shop. After furnishing and final painting, loco is dispatched to their homing shed. This completes the fascinating journey of loco manufacturing and rebuilding at DMW.